As economists, one of the things that we're most interested in is trying to guide policy at a very broad scale. So governments and donors have to make decisions about where to invest their resources in projects and programs. And so part of what we're trying to do here is establish some broad kind of indicators of the importance of agriculture and health as vectors or pathways to nutrition outcomes. And so if you think about the research in that context, I think it'll help. I'd also say that there's a paper that goes along with this, so if you're interested in the details, by all means see me afterwards and I'll get you a copy of the paper. For those of you who are familiar with NextSap maps of Nepal, this is a similar map for Uganda that shows pockets of malnutrition. Some of you may not be familiar with Uganda. It shares a lot of similarities with Nepal. It's a landlocked country. It has a very similar GDP per capita, has very similar population density, and it has very similar rates of childhood stunting. So many of the challenges that we face in Nepal are familiar in Uganda as well. One way that Nepal and Uganda differ is in terms of precipitation and moisture. And here's the spatial distribution of rainfall in Uganda across districts over a 12-year period. The mean rainfall during the growing season is about 450 millimeters. That compares with about 281 millimeters in Nepal, so a much wetter environment. And so there's some key points that you might take away from this graph, and that's that there's pretty wide variation in rainfall across the landscape in Uganda, and even within districts, there's quite a bit of variation in rainfall. So that motivates some research questions. So first is, are child nutrition outcomes or growth outcomes sensitive to rainfall, and what might be the impacts of rainfall via agriculture and nutrition? So conceptually, the pathway that we're thinking about is one in which agriculture and health feed into nutrition, and rainfall drives agriculture and health. Now, you might ask, why the focus on rainfall? Rainfall is not a policy variable. We can't do anything about rainfall. But from a research point of view, rainfall's quite useful because we know that it's exogenous. Nobody controls that. And therefore, we can use rainfall as a method for detecting the importance of these and the magnitude of these pathways through agriculture and health. So to do this, we layer a whole bunch of data. We start with demographic and health data for Uganda from two surveys, 2006 and 2011. That gives us about 5,000 children under age 5. We take data from the equivalent of the Nepal Living Standard Survey. In Uganda, it's called the National Household Survey. And we use data from preceding years, years that precede the DHS, to understand something about agriculture at the district level, and we match the clusters from that data set to the DHS clusters. Then we overlay rainfall data from CHIRPs. Those who might be familiar with that, those data come from NASA and NOAA, and those are highly resolved data that cover a very long period, and that's useful for us because we can look backward into a child's profile and look at rainfall situations at particular times in the child's life. And then we also add temperature data because we're actually interested in growing conditions as well for agriculture. And those data come from the Berkeley Earth Surface Project. And those are monthly gridded data as well. Okay, so that's where the data come from. What do we do with it? Well, we start with the DHS surveys, and the DHS surveys collect information on child anthropometrics, and then we look backward in time and match data from the household surveys that give us information about agricultural production, and then we lay on top of that precipitation data. And we're interested in precipitation at two particular points in time. One, the time just around child measurement to look at the health vector, and then also precipitation at the time of agricultural production to look at how precipitation affects growing conditions and yields. So I'm going to show you some pictures that just kind of illustrate patterns in the data. First is that in terms of temperature and rainfall, Rainfall tracks weight for height z-scores quite closely, much more closely than temperature. And if we think about agricultural's impact on yield, it depends quite a bit on where we're looking at yield. So this is rainfall on the x-axis and yields on the y-axis. And as you can see, at very low levels of rainfall, children might benefit potentially from increases in rainfall or improvements in agriculture that are rainfall sensitive. At the higher levels of rainfall, it may be the case that children could suffer from excessive rainfall just from negative impacts on agriculture. So when we think about agriculture and rainfall, it depends very much on exactly where we're thinking about the rainfall and what point on the distribution that is. When we think about connecting the health vector to weight for height z, this graph shows the impact of a diarrhea indicator in the DHS data set on weight for height z. Of course, it's a negative relationship. The thing that's illustrated here, where each of these dots is a district level average effect, is that the negative impact of diarrhea is clear, right? But that association becomes much stronger at higher rainfall levels. So the magnitude grows in strength as rainfall increases. In the DHS, we only know something about the episode of rainfall, or the episode of diarrhea, whether the child experienced diarrhea in the past 2 weeks prior to measurement. This gives us some insight into the fact that it may be something about the intensity of the episode and the intensity of rainfall that's important. And these plots control for a wide range of covariates. The reason there are 6 of them is that each of them controls for a different set of covariates to kind of check the robustness of the result. Here's a different way to visualize the data. Temperature on the x-axis, rainfall on the y-axis, and then the map is the impact of diarrhea episodes on weight for height z. And what you see is the estimated impact of diarrhea episodes are highest in the high rainfall categories. So again, just kind of showing that effect in a different way. If we turn our attention to yields, the relationship between weight for height z-score and yield is positive at the district level. And the magnitude of agriculture's impact on weight for height z, so in other words, the importance of yield in driving weight for height outcomes is greater in high rainfall environments, okay? There's a lot of work in the paper, and for those who are interested in the details, I encourage you to look at the paper. We use multi-level regression to sort of combine all of these effects and study them. And so when we put it all together, we find the following. First, the models that include health and production pathways consistently outperform those that only include health or only include production. So in other words, we find evidence for both pathways, and if you're ignoring one of them, you'll do a less good job of understanding patterns of weight gain in children. Second, at a contemporaneous point in time surrounding the measurement of children, rainfall is significantly and positively associated with the likelihood of a diarrhea episode. So that probably is not surprising to us. Those results are very robust to the inclusion of all kinds of additional covariates, including temperature anomalies and mother and child information. I would note that once you include child level information in those regressions, the magnitude of the effect falls by about half. So there's a lot that's explained by children, but there's still quite a bit that's explained by rainfall. Recent diarrhea episodes have negative and significant associations with weight for height z-scores, and the impact of yield on weight for height is positive at moderate and high levels of rainfall. So I think the most important finding for this group is that we find evidence that these two forces, health and agriculture, are somewhat offsetting. So we find that at very low levels of rainfall, the yield effect dominates because low rainfall means low yields, and that drives down weight for height z-scores. We find low weight gain among children in those environments. Low yields equal low weight for height z's. And then at high rainfall, we find negative health effects offsetting any positive crop yield effects, right? So the take-home policy message, again, from the point of view of how do we allocate resources at a very broad scale, is that you need to target agriculture in dry areas, and you need to target health in wet areas. So that's the finding that I would leave you with for consideration. Thanks.